Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. As mentioned before, the ionic compounds, which is it show the numerical charge of each atoms. So we can give the compounds name by the way is to also state the charge unit that they have. In the table periodic, we know that the ionic compounds, for the basic principle, it is bound by the metals and non-metals element, which we can see in the table periodic. Now let's start with the ionic compounds name that it contains cation and anion. Remember, the cation is the element that act as cation is metals, which the metals also has two kind, which the elements could be give the charge number only one, and another element could be give the charge of element more than one. So we will start from the first for cation that come with the metals that give the number charge only one. It's come from the group A1 to 1A, 2A, and additional elements such as silver, zinc, aluminum, that is an additional elements, and when they make an ionic bond with the anion, we can state the cation with the name and followed by the anion with give the "ide" ending in the last name in the name. The "ide" ending is also used for certain anion groups containing different elements such as hydroxide and cyanide. Thus, LiOH are named as lithium hydroxide and KCN named as potassium cyanide respectively. These and a number of others such as ionic substances are called ternary compounds, meaning the compounds consisting of three elements. The certain metals, especially the transition metals, can form more than one type of the cation. Take iron as an example. When we discuss about the ionic radius, we can also know that there have where iron that have to charge with is one of them is with the charge positive 2 and the third plus 3 charge. In older nomenclature system that is still in limited use, assign the ending with "-os" to the cation with fewer positive charge and the ending of "-ic" to the cation with more positive charge. For example, Fa2 plus and Fa3 plus. For Fa2 plus, because it has fewer positive charge, so it gives the name ferrous ion, while the Fa3 plus, because it has bigger charge, it gives ferric ion. This method of naming ions has some distinct limitation. First, the "-os" and the "-ic" suffix do not provide information regarding the actual charge of the two cations involved. Thus, the ferric ion is Fa3 plus, but the cation of Chopper-named cupric has the formula Cu2 plus. So we can't predict what is the specific charge number of this element. So follow this condition, Therefore, it has become increasingly common to design different cations with Roman numerals, and this is called the Stokes system. In this system, the Roman numeral 1 indicates one positive charge, 2 means two positive charge, and so on. For example, I have manganese, or we can symbolize it as Mn. The symbol is Mn. It can assume several different charge, Mn2 plus, Mn3 plus, Mn4 plus. So I can make the compounds such as when it's bond with the oxide, they could be named as manganese 2 oxide, manganese 3 oxide, and the manganese 4 oxide. Use the Stokes system. That is the name for the ionic. Second, how we can give the name of molecular compounds. Well, unlike ionic compounds, the molecular compounds contain discrete molecular units. They are usually composed of non-metallic elements, and it could be also composed by metalloid and non-metallic compounds. Some of them could be binary compounds with it contain only two elements, such as HCl, which we can name them as hydrogen chloride, HBr, hydrogen bromide, SeC as silicon carbide. And it is quite common that for one pair of elements to form several different compounds. In this case, confusion in naming the compounds is avoided by the use of Greek prefix. The prefix to show how many atoms element involved in the bond in compounds. We use prono, D3, tetra, and so on. But sometimes the prefix mono may be omitted for the first element. For example, VCl3 is named phosphorus trichloride, not monophosphorus trichloride. Okay. For the oxides, the ending A in the prefix is sometimes omitted. For example, N2O4 may be called the nitrogen tetroxide rather than the nitrogen tetraoxide. Let's check the concept, how you can try to give the name of it.